Righty-ho, good evening everyone, and welcome back to another live stream. Hello to everyone that's joining us. Joining me, with you, I don't know, whatever. Today we're carrying on the Voron 2.4 assembly, and we're going to be doing as much of the electronics as possible, hopefully all of it. So between the last stream, which was about a week ago I think now, and now, I have actually sort of prepared all of the wiring and stuff, so it should be pretty quick to get it all together. I've tried to be as organised as possible, so we can kind of talk through it just without the hours and hours and hours of wiring, which has now mostly been done. So, I do have to remind you that since they provided parts for the stream, it's technically sponsored by LDO Motors, OneTwo3D and BigTreeTech. So big thank you to them for providing stuff. And of course we are building this Voron 2.4. And sorry for being a little bit late as well. Things are just a little bit hectic this evening. But hopefully we'll be getting everything going and it'll be nice and quick. Is there anything else we need to cover before we get started? This looks slightly wonky for some reason. Maybe it's just me. Good evening, good evening, good evening, good evening, good evening. The wiring electronics live streams tend to never be quite as popular, unfortunately. But there you go, that's the way it is. I just realised it's really warm in here, so I'm going to just open a window quickly to hopefully keep me fairly cool. Oh, the window's already open. I'm going to get a fan, back in a second. I've put it somewhere and forgotten it. Such a professional live stream when you forget things that you need and you're not here right at the beginning of the live stream. Right, okie dokie. So the plan is mostly wiring. Hopefully things are fairly organised and we can sort of just get on with it. Is there anything else I need to know about skirts? Let's just check instructions in terms of where we were and where we're going. So this was putting all the kind of electronic stuff in the base, which I've done. Controller. Ooh, there's some additional information here. I didn't see this before. Let's flip the printer back and have a look at that. You'll see a cable already installed. I decided not to take that one out after doing a bit of brief setup. Oh, look at that, it matches perfectly what I've got on screen. I'd like to say I planned it, but I didn't. So you've got a jumper here, remove this to avoid interaction between USB 5 volts and the 5 volt of the MCU. Sure. That's that gone. Remove all the jumpers on the fan voltage section headers so that you can set the correct supply voltage. Remove the jumper, so this is section 4 down here. I think this is the correct one that we want for all of ours. I believe they're all 24 volts. Maker Man's purchased OneTwo3D kit for 2.4, very, very nice. How's the heat wave in the UK? Technically over, I think, but it has been difficult. It's very warm. And I'm not good with heat at the best of times. Number 5 is remove the jumper in the Pro voltage selection header so that you can set it to the correct supply voltage. And it's a 24 volts, so that's actually not what I want for the probe I'm using. That one I've done, that one's empty. In for 24 volts. 2, ensure all the jumpers in the diag section are removed. Yes. And 5, we don't have 24 volt probes, so that's okay. Stepper drivers, Octopus pin out, wiring. Mains wiring, wiring, wiring. Okay, so I think we'll get started with power supplies. So this is the layout I'm going with. I think I've got everything there. Obviously the front of the printer is up here and the back is then obviously facing down. So we've got the screen coming out the front. This is Raspberry Pi obviously. That's the Octopus Pro controller board. This is the USB to CAN adapter board. So that feeds the CAN for the tool head, SSR, 48 volt power supply and 24 volt power supply. I've put additional writing on here just to remind myself. It is written down here, but it's in tiny little text, whereas this is easy to find if I'm looking at it quickly. So, I had a bag of wires and it appears to have disappeared. Aha! What did you miss? Not very much. So this is all the wires. I've actually not really started yet, so you've actually literally not missed anything. Ooh, that's a bit close to that. So as you can see, these are all the wires that I've sort of pre-made. We should have all the mains, all the SSR, all the stepper motors, the CAN board, like all the wiring is here, I think. I might have missed some things. If I've missed anything, I'll just maybe make it at the end or as we go or something, I'm not totally sure. Some of it's even like pre-cut and pre-assembled just because it's going to be much quicker to do and we don't want to spend too much time faffing about with the wiring. I think what I'm going to do is actually flip the printer onto a different side. I think it will be easier. Like so. Oops, no, this, but this over here. So I think we probably just want this angle for like all of today. So for the mains wiring, it's pretty simple affair. You got, for 2 power supplies, you don't connect them to each other necessarily, particularly down this end. This is the input end. So you've got 2 earths, 2 browns, 2 blues. Mine should be the shorter length. So we've got this short brown, shorter blue, shorter earth, and longer brown, longer blue, and longer earth. Am I going to be able to pull this here, here, and here? So, lost my screwdriver. Cool. So, obviously you do need to wire up all of these. Hopefully that goes without saying. You can't just leave some wires out. You got earth in green and yellow. Mine should be cut to length. That's kind of the right length. That goes in there. And you have the neutral blue, which I always, for some reason in my head, is live, just because it's a more lively colour, but it's not. That one's going in there. And then we have the live in brown, and that's going in there. And then the same thing, but for the other power supply. You can't really see those Wagos particularly well. They just have a little clip on, so you lift the clip up if I zoom in here, you lift the clip up like this, and that releases the metal catch that's in here. You push the wire in the end. You have to crimp quite a lot off the end. Push it in until it touches the end, just gently. Flip it down, and that's obviously that. Do not connect earth to this. That was just as an example to show you how the connector works. So everything that's in one of these blocks, all 5 of these, will be connected together. That's how these Wago blocks work. So I've got 3 blocks here, each with 5 terminals each. And that gives me enough connections to connect the power supplies to each other, to power supplies to the mains, and also the SSR. And then we'll also run a ground cable for the bed later on. Much quicker when you don't have to cover the wires as you go, eh? It's taken me many hours doing all this preparation off stream to make the actual live stream hopefully a little bit quicker. A little bit more information dense. I think it would have been like 3 live streams worth of wiring if I did it all live. Because it's a little bit quicker when you're following a guide, because you know exactly what to do, you just have to do it. Whereas obviously when I'm working stuff out a little bit from scratch, because this printer's not exactly completely standard, it just takes a little bit longer to work out what you're going to do and then do it. Oh, goodness me. Then obviously if it doesn't work quite right, quite how you expected, then you have to try again. Blue in the middle. Oof, why is this one not quite long enough? Hello? It must be long enough. What have I done there? What's going on? Oops, daisy. Let's take this out of here, wire it in, and then put that on afterwards. There you go, plenty of length that way around. Weird why that's difficult to put in. Anyway, that's pretty much the power supplies connecting up. So now we've got, when we plug in here, it'll do nothing until we turn on the switch. And then obviously they will have power to these 2 power supplies. Now we've got to get power supplies from these to the other stuff. So the first part of that is to connect the 2 power supplies together. When you've got 2 power supplies, they have they each have a ground and they each have a positive rail. Obviously one's at 24, one's at 48. But to make sure everything works together, you have to make sure that those grounds are kind of working on the same reference, if you like. So we connect them to each other via the negative ground. And that way they will both they'll have the kind of 0 volt reference in the same place. So that's just a single cable. What's next? Excuse me. Leave it as it is without the wire. It's going to look pretty clean. I've got all these like black cable covers on all the wires, so hopefully it'll still look pretty clean-ish once the wiring's done. So because on these power supplies there's only a couple of positives and a couple of negatives, like if we were to do just these straight to control board, we wouldn't have enough, like, because you need a positive and negative of 48 volts to here, positive and negative to here, and then you need another one of these into here, and then another one of these over here or something. A few places. Anyway, the point is you have to split them out in order to get enough terminals to do what you need to do. And so obviously more Wagos for that. So 5-way Wagos again. All these are nicely pre-made for me. Well, they're pre-made for me, but also by me. So down here we have positive and negative. Where's my screwdriver gone? Let's do this one. So obviously try and keep the wiring colour sort of labelling sensible. So if you're going to try and theme a colour, you can kind of change the red to be sort of a different colour if you like. So you have your coloured wire as a positive and your black as the negative. Being consistent is the most important, I would say. So these two are going into here, and then this one is going up over here. So this device up here, as I mentioned just now, is the CAN, a USB to CAN. So you plug in USB from here to the Raspberry Pi, and then you have the CAN output, so the Raspberry Pi is communicating through here to the toolhead board. We need 24 volts for that system. So we're going to do that straight under here, and again making sure we get our colours the right way around, and it's not obvious on here which is negative, which is positive. I might just take the is it, I think it's brass insert, so we're okay to do that. I think there's going to be some better indicators on the underside to tell me which is positive, which is negative. There is. So you can see here, sort of, this way up maybe. Yeah, so 24 volts is the outside one, then ground, then CAN high, then CAN low. So VCC, yes. Okie dokie. So let's put that back. Bibbidi bobbidi boom. Bish, bash, bosh. Right. And then we've got this to go in here. So these are bootlace ferrules, so a crimped terminal on the end. A little bit of a pain to get in these holes. Somewhere I've got some little tweezers, but I don't know where they are. Just makes it a little bit easier to grip things. I should use some needle nose pliers. Gently. So that should go in here. There we go. That's on there. So that's 24 volts, so that should power that board. Now, next one. So we've got two lots of same length here. These are both going up to here. So we need one to power the main board, and one determines the power that we use for our switcheroonie here. This is switcheroonie. That's an SSR, so a solid state relay, and that's what's going to turn off the mains power to the bed. So that's rated for 3 volts to 32 volts, so obviously therefore we cannot use the 48 volt power supply, and that's why we're splitting out this one to do the power and the bed power. And then this one will be motor power. So we need to flip this, what's it up here. I wish there was a better way than screw terminals for these, because they just take a little while. I've left these ones a bit loose so they're a bit quicker, but just even like the crosshead stuff is just a pain in it. I wish we had better ways. So negative that side, positive this side. That's going to go in here. Then these two on the other ones. So these follow the same pattern, minus plus, so let's just double check. Oh, I've used a kind of extra thick wire gauge here. I just picked something out and used it for basically everything. So it's a bit thicker than it needs to be. Well, it's a lot thicker than it needs to be, but it also fills the sleeve a little bit nicer, so that's what we got. And I think that looks pretty tidy. As tidy things go, this wire up the top is not super tidy. I suppose I could explain that as well while we're here. So in this instance, I'm going to be powering the Pi and communicating with the Pi through this single cable. So this is just a 5-pin DuPont connector. In my case, it's actually a 4+1 pin DuPont connector. I wish it was a JST-XH, but the header is for DuPont. So this has 5 volt, 5 volt, ground, TX and RX. So the TX and RX is your transmit and receive for UART, which is the communication method which we're using between the control board and the Raspberry Pi. And then the reason you have 5 volt ground is because that's the same pinout that you have on the Raspberry Pi. So from the top left corner here, it goes 5 volt ground, RX, TX, TX, RX, whichever way around. So that's what that cable does. I've left it in because it was a 4+1, can go the wrong way around, all this kind of stuff. So I just worked it out, did it, and then I'm just going to leave it there. Which is why I'd like it to be JST-XH, so you can't put it in the wrong way around. But you're going to be stuck with whatever on the Raspberry Pi anyway. So there you go. Now, what a lot of babbling I'm doing today. It feels organised, doesn't it? It's so weird. Oh, the STL file for this, I've not published yet. It's actually not very good. I modelled it with this facing this way and this facing this way. And then obviously when I did that, they don't fit. They're like mirrored opposite. So it looks like it works, but it's a bit shit. I will upload that at some point when I remember to do it. Next. Got this wire for something. There's remembering what all the wires are for. I don't remember. That's motor, that's motor, that's motor, that's motor. So we've got our 4 motor wires. I think these are for the SSR. We did those separately for reasons. And there's another pair here. What are these for? Ah, this would be the 48 volt. So let's do the 48 volt for the motor power. So again, I'm using these headers. So 48 volt one, we don't need to go via the Wagos because it's only going to one place. yes, it is a massively overkill power supply for the amount of power we're using. I believe it's 200 watts and we're only powering 2 motors. Like, they can draw really high current technically, but I don't think we're going to be using too much of this power supply's rated power. This goes up here, again, same way around, so make sure you get in the right way around. The reason you have to check and not just copy the ones next to it is if you look at the end, the bed out is plus minus. So it goes minus, plus, minus, plus, minus, plus, plus, minus. Just so you know. Always worth double checking what the labeling says before just doing it. I think it probably looks clean at the moment because I'm not finished yet. There's still lots to go on here. So let's just snug these down a bit. You're pretty limited by torque that you can do with a silly crosshead screw like that, but there you go. That's in there. So the last ones here are then bed out. So this is one's going to switch the power supply, the SSR on and off, which in turn obviously switches the bed on and off. So because, I mean, I've done them separately. You could have done them in one cable, but you have to make sure that they can split to these 2 terminals, obviously. So take these terminals out. The other side we'll do in a bit once we've got the bed installed. We should be doing that today as well, so. Because, you know, planned and organised. So this is the black cable, and as we mentioned, it's opposite way around, so negative on this side. Oops, let's actually do it this way around as well. This goes to negative on here. Oops, it is it. And then the other side. Ooh, this is looking a bit long. It's okay. We can obviously move this a little bit if we need to, so we're not overstretching those cables at all. Make sure these are nice and snug. Don't want them coming loose. And that's all of those then sorted. Cool, I told you this wiring would be quick, didn't I? I wasn't joking when I said speedy wiring. Half an hour and we got a whole load done. So we'll leave the cover off for now. Oh, here you go. There's the tweezers. I knew they were around. Next we can do the motor cables. Now, because I got the LEO motor kit, it has these little tags for the motors, and they will label all the Z motors, AB motor, so that when you wire them in, you don't mess them up. I don't know which one's technically which, so I'm just going to leave them for now and maybe do them later. So you do need 4 completely separate different lengths for these. Obviously this motor is right next to the control board, so you don't need a very long cable. But on the other hand, this one, for example, is right across the other side. So we've got a super long cable for that one. Blop. Now, in terms of routing, you've got these 2 big power supplies here, which is like really not ideal in terms of like electrical noise with this wire. So I don't know how well it's going to be. I'm going to probably shove it down between the 2 power supplies and hope for the best. But if we have problems with that motor, this will probably be why. Now, in terms of wiring stuff in, if you remember before, we already put in our drivers in the positions that we need them. So we've got the 5160s for A and B, and then 4 for the Z, and then the E motor for the extruder is on the toolhead board. So we've got A, B, and then I believe this is like a double connector for this one. One of them has a double connector. I forget which one's which. We might do a quick double check on the GitHub just to make sure we don't get it wrong. Oh, actually, the wiring diagram is probably on the instructions just here, isn't it? Yes. Oh, no, sorry. This one. So you can see M0, M1, M2, space, M3, M4, M5, M6. So I can't see where they're labeled. Where are they labeled? So it's, it would normally A, B, X, X, Y, Z, E. So it's X, Y, Z, Z, E, 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 E. I think, right? So basically X, Y, Z, X, Y, Z. So one of them goes in here. Oops. And then we have a space, and then we have a motor. So we go in here. I want this to hide under here nicely. And these two are about the same length. Looks like they're going to be basically the same length. Oh. One is shorter, so which one's closer? This one's probably the closest one, right? That's close to here. Yep. So that can go on here. Bibbidi bobbidi boom. Up to there. That can go right next to here. Hopefully, like so. There we go. We can add some zip ties or whatever if we fancy later. And then this one is for this motor, which we shall route up over here, past the pi, down over here, through here to here. Maybe we could go through, actually I might do that instead. Let's go straight through here, past the cable, straight under here. It's going to turn out a little tidier, I think. Pretty happy with that. What's next? Oh, we have some other motor cables. That, and that, and that, and that. Okay. So I think we'll leave this lot here for now, and we need to flip the printer over to the other side. Put that on and take it off again later. Okie dokie. So the next thing to look at is the clockwork afterburner. What's it doodah over here? It might be quite difficult to see what's going on with this because it's tres tiny and far away. So I need the thing. So I've designed a little different bracket compared to the ones that are currently available to mount all these things. So where's that? Here we go. So it looks like so. Whoop, somewhere in here. And it's a little bit different to what already exists because it sits the board much closer to the motor than the other ones that are around at the moment. There should be a nice one coming soon that has a whole big cover over it and stuff, because there is a concern with this one with the exposed wiring that it could catch on the drag chain. So that'll be interesting if that happens. But hopefully it won't. So this sits just on here. So there are some posts that I've made as well. You can see those in there. So this sits on top of that lot. Hopefully just aligns nicely like so. Screws go in here. In fact, it might be easier for you to see if I do it this way around. I don't know, it's not ideal. So that's that lot on there, and then this just plonks straight on the top. And this is where we have to be super careful. One thing I have done, which you might notice down here, is I've added an X end stop. Now, this board, while technically kind of great, is not optimized for Voron particularly, so the wiring setup is not ideal. So at the moment I've actually got loads of end stops installed because I've got the two XY ones on here and I've got another XY on here. This one I'm not going to be wiring in, so it won't actually be used, but it is going to be there. And I've just remembered it's going to be easier to wire in the heater before adding this tool board onto here, because the heater plug is kind of annoying. So heater plugs using screw terminals, but I don't want to have really long things sticking out, so we're just going to put the wires directly into there. Oh, that's too long. How is this controller not ideal? Well, so when you have a probe and an XY end stop in one place, you kind of need multiple grounds. You need a ground for this and a ground for that. They can be common on the board, but you do really need two places to wire them in. And because the pH connector here has one ground for all the end stops, and this connector here has a ground for the probe, because this is a DuPont connector, it's extremely long. It doesn't look that long, but once you get like a connector on the end of it, it ends up like all the way out here. And because the Z drag chain is so close to the back of this, there just really isn't much space for that in this orientation. So there just would be design optimizations for a specific Voron designed one, which I would very much like to have because of those reasons I've just mentioned. Love those seagulls in the background. Maybe I should like have some like nautical themed layout on my stream, just because of the noise of the seagulls. So heaters. So this connector is a screw terminal. I'm doing it off because it's very much easier to poke the wires in when you can see what's going on. If you try and do it when you can't see it, you're just going to stub the wires and make a mess. So, oop. I'm a little bit concerned about the power draw of the. Oh, this. Where's the side cutters? I'm a bit concerned about the power draw of this heater versus what this controller can actually manage. So it is a bit of a hope and see at the moment. Because hot end heater powers are just getting a little bit ridiculous. What I might need to do is just limit the PWM of the heater, which will in turn limit the maximum current that's drawn, apart from in a failure scenario, I guess. But that should be enough to for like sensible usage. Let's get this down here. Right, that's that on there. So now becomes the difficult bit. So we have to get all this wiring connected into all of these, but also as flush as possible, because anything that sticks out, if you see from maybe this angle, the drag chain is going to be in here. So any wiring that's sticking out is not necessarily going to get caught, but has the possibility of getting caught. Which is why the upcoming design that's kind of got a whole cover with a fan would be ideal, but there's not actually even anywhere to plug in a fan very easily, so yes, very much all not ideal. But it should work, and that's the most important thing. So this connector is here, and that does our probe. I've actually got one pin of the end stop, but not the other one. Couldn't be bothered to take the other wire one out. So basically we have to then bend this round like this to make it super flush when we do the wiring, or the zip ties. Zip ties are going to be absolutely key for holding all this stuff in place. And then we've got a couple of, I forget which is the fan and which is the other thing. So we've got lots of tubing connectors. This one over here is the NeoPixels, which we did before. And then we've got 3 tubing connectors. We've got a thermistor and 2 fans. I believe the thermistor was the one next to the NeoPixels. So that's going to go in there. Like so. And then we've got 2 fans next to that. I think it was the white fan first, and then the black connector fan. And as you can see, there's already a big mess of wires. The last thing we need is obviously the CAN wires, but we can do that after we've got this pile of shit sorted. Right. So I don't really want to cut this wire off, but I also don't want it hanging out. Oh, screw it, let's cut it off. If I need to add X end stop, we shall do some new wiring. So, I need a couple of zip ties. And basically we're just going to kind of train all the wires around the back and zip tie them into place so that nothing moves. So I've put some slots on the back here. So that'll stick out there. We'll just put as much into that as we can. cinch it down, job's good. Hopefully. And hopefully we don't break the 3D printed mount, because that would be problematic. So, I think NeoPixels look like they can go. Basically what we're doing, we're trying to use as much as this void. So there is like this huge cable void on this side, which is, I think, so you can have lots of cable space and toolhead board and stuff in there. Obviously our toolhead is on the back toolhead board, so we're going to use that space for all the excess wire length. So I just want to kind of carefully bend the wires round, all kind of fairly even length. Try and train them into this spot. Maybe we can pull these upward instead of down. So I think there's that in there, that in there, that in there. Okay, so we've got the probe, we've got the motor, and we've got the NeoPixels in this zip tie. So as I said, try and pull the cables through so everything sits in a good place. Oh, I've caught extras. Oh, nitwit. We put those under here. That one also needs to go in there. So that's then the 4 lower cables. Let's get those sealed into there. And we just sort of pull them through, tighten it down, job's good. Sort of. Mostly. It's more like job's acceptable rather than jobs are good. I kind of want this. Told you this would be fiddly. It's just important that we get things in the right place, because otherwise the cables will hit stuff, and we can't have that. Okay, that's looking reasonably good. It's all snug. I mean, there's no way I'm going to pull anything out accidentally, but we've got clearance. We're just about in front of the extrusion, so hopefully enough space there. Now we can do the top ones, hopefully have the same result. Just going to arrange these wires that are coming out of the connector in such a way that they don't sort of tangle each other as much. Hopefully a bit. No, they're kind of tangled naturally. Oh well, okay. Just don't want them to be causing problems for one another. There we go. Okay. Now we just have to tuck all the wires into their available spaces, and hopefully the whole thing will just work. Configuration pending. Oh, that's snug, isn't it? So we've got the motor cable should tuck under that nicely. What do you think? Chance of success? Hopefully reasonably high. So we do also have a heatsink that's got to go on here. I believe over here. So there's two like silicon die things, kind of obvious ones on this chip. There's one over here and there's the one in the middle. So the one in the middle is like the CPU controller, and I believe this one over here should be the stepper driver. I can't really see because it's kind of dark, but if I get a light, hopefully I can read it. I'm pretty sure it's a 2209. You can see the logo. Yeah, so that's the TNC 2209. That's what we don't want getting hot. So in here, oh, there was, or is this the, that's the wrong box. I just obviously put it in the wrong box. There should be a heatsink. Yes, a little blue heatsink like we often have for stepper drivers. We should be able to install that. Hopefully it doesn't come off or anything like that. Because there's very little airflow, there is a concern that it could potentially overheat, especially in a heated chamber where the ambient temperature is going to be like 55 degrees Celsius. Active cooling would be better. So this is another thing that would be a nice addition on this control board. I mean, it's very difficult. Look, there's barely any space for anything. But a fan header. We need a fan header for active cooling of the components. So hopefully that there will help the situation. A very small heatsink. Now, what's going on here then? So now we've got to do some wider angle stuff. We need drag chains. We're not going to be using a drag chain here, so here to here will be no drag chain. But we are doing a drag chain from here because I've still got the standard end stops for that. So we need to install drag chains for the Y and for the Z. So where the hell are they? I'm looking for the mounts as well as the... here's the drag chains. I've made those hopefully about the right length. So it's not that long. It's not there. Where's all these parts? Have I just put them somewhere silly? Pretty typical. Chat's super quiet today. Why don't you let me know what you've been working on? Excuse me making a 3D printed thing. Packets, doors, enclosure panels. Extra afterburner truck workpieces. That's the bag I already looked at. Oh, that's got that. Do I need that? I don't think I need that. All that, all that, all that. There's a whole bag of pieces somewhere with all the critical parts in. I've lost it. Aha, this looks different. Yes. Ordered your lights. Good. Nice. The lights all sold out so quickly. I'm so sorry. There's also a bunch of people on back order as well. If you want them, more are coming. I will be putting these two, by the way, that's why these are here. These two are going on this printer. Probably don't need two because they're super duper bright. I'm putting two anyway. Making accessories for airsoft, nice. What's my experience with the BigTreeTech Octopus Pro? Well, it's kind of non-existent. I've got one on this build, so I will be obtaining experience with said controller, but current experience sits at 0. Hello Ricky B. I just built a Fly SHT36 cam board on my Ever. Nice! I think that's enough for now. We've got loads of things to install. Oh. One of the mods I did previously, which is, I mean, about as simple as it gets as a mod, is literally just this little zip tie holder thing. So I use these to hold down the wires that go through drag chains. The question is, which one's for the XY and which one's for the Z? I think the longer one is for the Z. So this is going, oh no, this one looks like Z. That one's going to go here, that one's going to go here, that's going to go here. Well, that's not going to work, is it? That's got to be that. That's going to go here. I think I've just put the thing back on the wrong way up, haven't I? That's what I've done. I've been a silly. I've done a silly. Oh, I shouldn't have asked, should I? Now there's so many things to read, I can't read them all. Oh, and I've got something in my eye, it's kind of annoying. If only I would send a 350 Trident kit, I would be working on that. So many people are buying kits, it's been difficult, I think, to keep up, anyone to keep up. Is Vector with a K a shop? That's not good. The shop's been really popular actually, so thank you for everyone who's supporting through buying things on there. It really is helpful, so I do appreciate it. Thank you. My Trident is down because it decided to Z negative nozzle in it and bought the spring. Oh dear. Don't want to do that. So that's here, that's here. This is the one up the wrong way. So I'm going to flip this connector over. These are never that easy to do. If you're doing these and you're thinking you're pulling it too hard, just pull harder. They seem to be indestructible. I don't think I've ever broken a drag chain link. They just seem to be like infinitely flexible. That said, I'm probably going to do it now, aren't I? So this needs to go on after the cables go in because reasons. Oh, where's this come from? Is it broke? No. Okie dokie. So Where are you on your project to build a VZBot printer? So, announcement time. 3D Mello have really kindly offered to provide me a VZBot kit, so the 235. So they're going to provide whole bomb kits for me to build at some point. It won't be immediate because they've obviously got quite a lot to work on in order to get a kit made, but it will be coming and it will be done, so that's exciting. So this is the cable for the AB, I suppose, end stops. Actually, no, there are XY end stops, aren't they? Because although the motors do AB, the end stops do XY. The only thing I regret with the daylight LED or daybreak mod LED was not buying more. Should have got more made, is my mistake. Sebastian Jackal with €5. Thank you very much. Will you be doing some more dedicated videos on the details setting this up? That's a really good thought, and it's something I've considered as well, because quite honestly, I need to learn how to do it. I do not know at this moment how to do that. I don't know. I don't think it's going to be that difficult or involved, but I think it's something that will be useful for people to know. So potentially, yes, because it's something I've already thought of myself. Now, in terms of screws here, we could use, I mean, the right thing I think would be some very short M3 countersink screws. But because my drag chain just has barely anything in it, it's literally like 4 tiny wires, I'm not going to be too worried about making sure we've got loads of space, because we've got loads of space. If you see what I mean? Like, we don't need to optimize the available space because we've got absolutely boatloads of it for what we're putting in here. So that was a noisy seagull, that one. This is not screwing, oh sorry, it's not screwing into the extrusion, by the way. I've just already placed the nuts in here. As I said, I'm actually prepared for this stream. Not something I've ever done before, I don't think. But even, I mean, how long have we been going? An hour. There's still a lot to do. So hopefully this all the way to the front. This should just kind of pip up here. It looks like we might have one too many. What I'll do, get this in here. That's going to hold our cables tight. I think we'll do it this way around. And then we can move our, oh, this is too, we need a shorter screw for this. I think I have, I'm just going to go get some other screws. Hang on a second. I've got some M3 countersink screws hopefully back here. They're a bit shorter, so I think these ones are going to be maybe a little bit better. If not, I might have to find some M3x6 screws. Yeah, that doesn't actually fit because the head's wider. So we need to find some M3x6mm screws. Do I have M3x6mm screws? I must do. How did I do it before? M3x40s. M3x50s, M4x6, M3x6. There's just a tiny amount of them for some reason. Well, don't know what they're for, but what's my day job? This is my day job. This is literally what I've been doing for a living for a little while now. It might not be for much longer, but it has been for a while. So that's in there. Now we can grab that drag chain, pull that down there. So that's far down here, and then this is here, so that should fit, bend nicely around here. It looks like it could be one chain shorter maybe. It looks a little bit long, doesn't it? Could we... It's tempting to try and pull out one chain, but that might be... I suppose we can adjust this. I'm going to pull out one piece. I was a design engineer. Grab this over here. Pull that out of here. That over here. That's that chain out. This back on here. Right. Yeah, I think that's going to be a better length. Can you actually see what I'm doing? Kind of. Yeah, I'm happy with that. That's nice. I am going umbilical, but I still need this for the end stop because reasons. So I've got both worlds. So I'm going to get some extra screws in here actually. Space for 3, and I fancy using all of them. Seems you have a good sponsor. I don't have a sponsor. What are you talking about? No one's paying for this one. I know. I've got an in-stop on there. But because of the CAN board, it's a pain with the wiring and the grounds and the... So I've just done it this way. We may change it, but I'm doing it this way. I spent long enough faffing about with wiring already. I just want it done. And this way will work. So there's a little channel here, which you can slide away. See, these will poke nicely in here. These come up here, and over here, and then over here. So now we need some drag chains. Senseless. That's oh dear. I could go senseless homing, but that would be totally senseless. Essentially, it was easier for me to put stuff in that I later take out than not put stuff in and me to put it in later. Or put stuff in and just not use it is easy to do. So, in the hope of just making progress, I made a decision and I'm sticking with it. we have maximum options. We'll have 3 options for X-homing. We can sort it out when we get to firmware configuration, which will probably be a bit of a nightmare in itself. So that's that on there. This thing was meant to obviously deal with many more cables than this, so the zip tie holes are a little bit far apart for me, but it's fine. That'll still work absolutely okay. So that lot goes in there. Pull this slot through here. Try and keep it all the same length. Like so. And then that's what this cable tie thing is for down here. We then put this through these. And we can grab those to that. You can't see. I should have moved this up when I was doing this stuff up here. Oh, look how much better that angle would have been. Life of regrets, eh? So I want it about here. Oh, I probably want it the other way around. I've changed my mind. Just because these wires have got to go up over here. So if we move the zip tie back a bit, it'll give us a bit more room to do that without smashing the wires against anything. So that's that. Got it all tangled here. Mangled, tangled and everything. Right. Now we come around here, we've got all this bundle of cable, and this now needs to go through this slot here. Let's just zoom out. And then we come on to the next thing that I've modified. So around here there's normally a little cable guide which does actually look basically the same as this, but doesn't have this hole. That goes around here, put this in here, and it holds the wires in the place so they don't get caught on stuff. But because I've got the CAN bus in place and we'll have an umbilical that's going from the tool head back to here, I've modified this so that I can put the CAN tool head through here. So this needs to come here. So this end is going to plug into the tool head board, and that has to go through this hole here, and then it will be zip tied on here, and that will be zip tied over there. Whoopsie-daisy. So this goes on here. This goes over here. Oh dear. It's just a big bundle of wires. That needs to go down, come under here. So just want to make sure that all these cables go into here and down there. Right, so that will connect like with that. Kind of see maybe. So you can see where this braided cable comes out the top, and that will go to the tool headboard. I think mine's actually a bit long. Hopefully I'll be able to just kind of push this down and sort of adjust the length that way. Might not be very easy, but hopefully that'll work. That connects in over there. It's probably going to be a bit long, but we'll see. Let's get this screwed in. Is that going to be a long enough screw? I do not know. No, sir. Actually, before we do that, where did you get it? Oh, I made it. I make all the things. I haven't uploaded them yet. That cable's looking a little bit damaged. Hopefully it's okay. Yes, 300mm cube, same as the first one I did, which is my favourite size. In fact, I kind of want some smaller printers, but for now we're doing 300mm cube. I only want smaller printers because I have just limited space. Oh dear. Okay, let's ignore that for a second. We have to deal with motors. So we've got two more motors here, the A and B motor, for which I have again prepared cables. Ta-da! Oh, yes, cables. For some reason I have part of this connector not connected on this one. Because they've got to go through this. I don't know. We shall work that out later. Past me obviously had a good idea, but maybe didn't need to have that idea. Yeah, CBC2 is what I've been working on with that. That designer's been sending me the files as he went. So I'm seeing that, I'm aware of it, it's just not quite ready for me and I needed it right now. So we kind of have one here. I believe I made these the same length. Yeah, I did, didn't I? So these are going to go up here, and then I've put some things in here, so we can use these. A couple of those. Again, the nuts are already in the extrusion. Ow! There we go. So these are then going to come up here, onto here. I think we can move this out a little bit wider. Somewhere here. I want that to kind of be here. It's annoying. It's like you want this connector snugged in here, but it's not going to quite reach. But that'll be okay. And then we'll bring them to the middle and da-di-da-di-da. So this is where this is going to do this, this is going to do this, and then they both go to the middle before they go out to the drag chain. That way they're both the same length. So something like so. So we need one zip tie on this one over here. And they were just kind of relying on the stiffness of the motor cable to hold it up there. I mean, that's not going to go anywhere. That's good. And then for this one, we want so this rotor is going to come straight through. This one is going to come sort of folded back on itself, go to the middle, so like so. Maybe we'll put another cable What's-It thing in the middle there. Aim is both cables come out the same length. Oh, I've done one in there and one out. So match the ends, pull them down, doodle-doo, doodle-doo-doo. This one's much longer. That's same length, 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 there. That's where we want it. Ah. There. Grip, hold, something. Oh, it's too long. Okay, this is okay. This is good. Okay, okay. So I am going to put another thing in there. Build's going pretty well, I think, so far. There's a lot to do when it comes to wiring. I have spent many hours off of the stream preparing all this stuff, so as I'm installing it, it's quicker than it would otherwise be, but it's still not the fastest process in the world. So here we can then cinch those together, and that'll be nice. Cool. I always find this bit of the wiring a little bit weird because it seems like a bit of an afterthought. Like there's, by default, there's literally nowhere for these wires to go. Other things like here, like this is like quite specifically planned, but for some reason for these motor cables there's just nothing. It's just, I don't know, it seems odd. Like it was designed by two completely different people. Maybe it was. So there we go. One fan crimping a day. That's going to take you like a year. Lots of practice and you'll get there. I mean, it doesn't take me too long now. I don't make too many mistakes, I want to say. Like my crimping success rate is quite good, which makes it, stops it from being kind of really demotivating. I think I'm going to zip tie this on here now. Make a bit of a guess at the length and hope it's okay. Not sure how well this is going to work. Yeah, that's... I've not tested this. I designed it and then just like, yep, that's going to be fine. It does kind of look like it's a bit weak as well, so snapping is a possibility. Hopefully it doesn't. It shouldn't snap as I do this, but after some many hours printing, some light bending back and forwards, it may weaken significantly. Oh, I've tightened that one too much. Nitwit. Nitwit. So I think something like that is going to be okay. I can't remember how much Z room we have here, but we've got the motor body right next to it, so hopefully enough. Chop those down. I haven't necessarily orientated this the best way, but so now we've got to get the drag chain on. So this bracket, I can't remember if this is my custom one that I made before or they've just updated the design to be closer to it. I think it might be my custom one. But this works pretty simply. You jimmy that on there, jimmy that on there, stick that on there. Bob's your mother's brother. That's your mount ready. And then we've got to open all these on here again. Where did I put the flaps? Oh, what have I done with it? It's not in here. Or have I put it back in the wrong place? I've loosed it. I've loosed it. Oh, you need to it. There's a hex in here. There's a flathead bit somewhere. And it's gone. Where's it gone? Oh, can anyone see it? Anyone have any idea where I have put that? That goes there. So it's not in that place. What did I last use it for? Did I put it on the edge of this? Oh, it's over here. Gotcha. So, which way round does this go? That's what I need to make sure I get right. Not that way for sure. Not that way either. Where's it supposed to go? Can't do that. What have I done wrong? let me just check my other Voron to see which way round I have done it. This way. Right? Yes. So again, we've got to take this one off. Yeah, because it's like you have to put this one on sort of backwards. You have to take it off in order to get the connectors through. Do I have locking? No, my locking end's at the top. Isn't it? Hang on, I'm getting lost in my own brain. That's that way round, so that's that way round, so that's that way round, that's that way round. Yeah, the locking one's at the top. I mean, I think on this it doesn't really matter. It's not going to flop either way because there's plastic supporting both sides. So it shouldn't be floppy. From the inside is this way round. I shall continue this way round. This end unfortunately has to come off too. No, both ends aren't locking, but the supports that they screw to will prevent the hinge going backwards. I can see it would be... How many times have I checked this? So this is going in here like so. No, hang on, that's not going in there like so. Well, it is, but it isn't. That cable braid will not be in the drag chain when we're done, but it just needs to sit in there now because they're not long enough to do anything else. And then we need these motor cables too. These also need to go in here. Yeah, I have a slightly modified bottom mount, so maybe that's why. So I don't want any of these cables overlapping too much. I would say twisted cables like this are not really ideal for putting in drag chains, but that's what's happening. Right. Now hopefully we can pull this through. Oh. let's rotate it round, shall we, so you can see what the flip's going on. So this is going to go in here, like so. This slot's got to go through the hole in the bottom. And one of these, this has got to go on here, through here. There you go, yeah, that should hold on like this. Please don't be wrong, please don't be wrong. Drag chains can be really difficult to work with at times because they just don't, they only bend in one direction, obviously. Oh, have I made a mess of it? This looks different to what I've... Yeah, now this is doing that. Well, bugger me. Why did my other one work fine and this one doesn't? So we have to redo the whole thing. Yay! Looks to be working. It would be much easier to live stream with like having a camera person to do that, wouldn't it? That'd be great. I could focus on the building and you'd always have a decent camera angle. Right, so, second time's a charm. Tap controlled cam seems pretty risky. Sounds like a fun idea though. Not that I'd be able to do it, I can't really do software development, but. So we should have somewhere this thing, so we do this thing and this thing. This thing goes in here, that thing goes through here. And before you know it, we have the Z drag chain finished. Can't see anything. So then we can put this over here. Can't remember what screws I need. The 8s were definitely too short. And 3x12 sounds right. Whew. Well, that looks like a mess. So we don't want to pull the can one any tighter, but I think we want to try and pull. There we go. Those ones a little bit tighter. It's not quite what I was after. I don't know what this wire does. It doesn't seem to go anywhere. Oh, this is like this. Yes. There's an extra wire in here. Where's it gone? Here it is. The reason for the extra one is that the end stops have a wire for 5-volt power, because you can get end stops with a light on them, but mine doth not have such a thing. So I don't need that wire plugged in, so I have not wired it in, so reasons. So, let's grab this. As always, got a zip tie hole at the bottom of the drag chain to keep the cables supported. You'd think they're supported in the chain, but they're sort of not. Tighten that when we got the length final. Try and get the motors a little bit further in. I'm going to zip tie around this bundle for the CAN cables a little bit, just to try and support them a little bit better. So at least they're all sort of secured to one another, even if nothing else. And then we have to deal with the tool head. So this is where my arrangement so far might not be ideal. So in this big thing here, I've got the wires, but I've also shoved a piece of nylon filament. If you've seen my streams before, you've probably seen I use that quite often as a kind of strain relief device. It mostly works. So hopefully we can plug that in there, and then have some very tight cable management down to here. It's very, very tight. So as you can see, it's all a little bit not ideal. Cables are pulled a little bit tight and all this kind of stuff. But we're very limited for space here. So I just had to sort of accept that it wasn't going to be perfect. Hopefully in the future we'll have more options here, some stuff that's like a little bit better designed, rather than my thing, which I have made very quickly such that it works. Well, I don't know that it works yet, because I've obviously not finished, but the aim was to make something that works in as short a time as possible, which is what this is. And then hopefully as we get some more people doing the same thing, we'll have some better solutions that we can implement as an upgrade. So that cable's looking a little bit wibbly wobbly. It's not exactly how I want it, to be honest. It's going to be a bit not great. again, I think it's probably too long, but without finishing the printer, it was impossible to know how long I needed it. So it's got more than enough length to reach all the way to the front of the printer, as you can see. Let's get this sorted down here. Bit risky doing this when there's already cables in here because we might crush them under the screw. So you've got to be super careful. Yep, seems okay. And we do one on the other side too. That goes over here. So that's all right. Oh, this length is pretty good. Right. How long have we been doing? Nearly 2 hours. I don't have that much time today. I thought we'd get it finished given how much planning I'd done, but now I'm starting to think we might not. So next is the bed. Whilst we're up here. Where is it? Again, I've kind of done the wiring of the bed already, so that's all on there attached. So we've just got to mount it and plug everything in. Oop, try not to get stuff caught as you're doing it. Oh, oopsie-daisy, oopsie-daisy, oopsie-daisy. Oh man. Okay, let's get a couple of screws in here and then we'll sort the other ones out in a second. Where did I put the tweezers? Over there. This probably won't be the final adjustment of the bed and everything, but it just needs to be in place for us to do the wiring, because we obviously don't want the bed moving around when you're trying to wire it up, and once wired you don't want the wires to be taking any of the weight of the bed. So I'm going to wire it up, screw it in pretty solid, and then I'll try to remember to loosen a couple of the screws, allowing for some thermal expansion when we have finished the assembly. Whoops, daisy. 3 and the, oh, this one's not ready to go. Right, so let's just hold that in position so it doesn't wobble about. Oh, I've just realised we haven't done the magnet on the bed. When are we going to do that? Someone's just said, don't forget the magnet. I might end up doing it between streams or something. I'm going to do the wiring now, so I've got a full stream showing all the wiring. Because it's good to have a full stream having all the reference for all the things in one place. So what I've also attached into here is the end stop wire. So you can see the Z end to stop switch, which is this thing here. Little JST connector. That just pops in there. And the rest of it goes down with the bed thermistor. Down that hole. We've got our earth wire in here. That needs to go down the hole. And the two mains wires for the heater. Painter's tape. Oh man, those were the days. I don't think I ever really used painter's tape at all. Right. So I think that's all the top side wiring. Got this extra wire, that's for the SSR. That's the main top side wiring. We do have to do still like the camera and stuff, but we're pretty much there for the bulk of it. The complicated stuff, I guess you could say, is pretty much there. So let's finish this off. I do have to stop a bit sooner than I normally would today, so we won't be going for 3 hours. Oh, this is the other way up to what I had it before. Right, I just need a break for 2 minutes and we'll be back and we'll sort out the rest of this wiring. I shall see you in just a second. Right. So, forget how heavy this gets. It gets more difficult to turn as it gets heavier and heavier. So, all we've got to do now is finish off the rest of this wiring. So, the earth cable, that's got to come down over here. That's going to go into the Wago terminal block, as is this, and then that goes on here. So, wire strippers, we just got to strip off, I think it's about 11 millimeters, something like that, 10 millimeters. Is that enough? And then open the thing. Make sure it's going to all go in. Tuck that. Oh dear, caught it on something. Oh yeah, your laser system would have to be like 1.5 meters diameter or something. Absolutely huge. Not quite 1.5 meters. What is it, like 800, 900? I don't know. Huge. Be an absolute monster. So this is the bed cable that we've got to put through the SSR, and that's how it gets switched on and off. So one side goes in here. We have this other cable which I have made earlier. This goes on the other side. And it's the live side that we want to switch. So this is going into here. And then this one comes over into the blue zone. So that's that. And then we got this. So we got here the, where's the other end stop? What is this? Z end stop. It's the other way around, it's confusing me. So heavy. This end is super heavy now. Okay, this makes a bit more sense. This is the way up I was looking at it before. Let's yoink this over this way a bit. So this goes in here somewhere. I think it's T bed is the bottom one here, and then this can be like X, Y, Z, E. So we do Z's third one. Not perfect. Cable lengths are a little bit odd there, but it's okay, it's fine. We have 2 motor cables, one which needs the end putting back on it. Oh. There we go. I've pushed these tabs basically down just a bit too far as I've tried to release the connector. So they've just deformed, so I'm just bending them back up a little bit. You gotta be careful, if you bend them too far you'll snap them off. But that should be okay. So we want to match this one so they're the same. Okay. Black, green, red, and blue. These barely look long enough to get here, but hopefully they are. So I think we'll probably... Got no sleeves for these ones. Maybe I'll add them. What's the time? I'm not sure which one's A and which one's B, so... That's a bit of an eyesore going across there, isn't it? Definitely need some sleeves over these. We'll do that at some point. These don't seem to be as long as before. Hopefully it's still long enough. So we've got the can board going in here. Yeah, this sleeve is now way too long. I don't know how. So I forget which is which on these. I think this is Y. And this is X. We shall find out as we power it on which one turns out to be correct. Or rather, if any of that turns out to be correct. Oh, that's... I wanted that to go under this power cable, really. So let's just pull that out again. Yes, the AB motors are on 48 volts. Right, I think that's going to be as much as we're going to do today. I decided I don't want these as they are. They need the cover on to look tidier. Must look extra tidy. Them's the rules. I mean, they're not really rules, it's just what I want to do, so. So that's how much length we kind of need. Something like that. Let's give it a chop here. I don't know timing-wise what project will be next. There's a few things coming up. You'll have to wait and see, I'm afraid. Come on. As good as these split loom things are, they can still be a pain to get cables in. Oh yeah, VZ2.4r2 is already, that's already planned. Well, there's not dates planned, but it's so 3D Mellows has agreed to provide a kit. So whenever that's available, it will happen. I just don't know exactly when that's going to be. Can you imagine if I had to do this for all the cables today? The stream would have been hours. Aren't you glad I did a bunch of it beforehand? Even doing this one bit is taking forever. Now you can see why it took me so long to get everything ready for this. Right. So get this on here, give this a little twisty. Oh, which way am I turning it? What model? Okie dokie, right. That looks much better. So the wiring's not 100% confinished. There's still some lights and USB filament sensor and stuff to do, but that stuff should be pretty trivial. So I think we're past the bulk of the wiring now, which is setting us up to do all the other stuff that we need to still do, like the skirts and the enclosure and the firmware and all these other things that still need to be done. So that's going to be it for me today. This is now the end. As I said, a bit of a shorter one today, but hopefully that was good. I think that's about as fast as it's possible to do wiring, hopefully. It was just kind of plugging stuff in for 2.5 hours. Hopefully I explained a bit and that was kind of useful. No giveaways today, I'm afraid, but we'll hopefully be getting back to that in some future live streams. We do have more stuff to give away. I knew today's stream wasn't going to be super busy, so I was like, let's just not worry about it. How many people did we have? 60-ish? Maybe peaked at 70 or nearly 80. Oh, right. It's not perfectly clean. I don't like the Voron DIN rail thing, unless you have other stuff around it, is not perfect for managing cables. The cables aren't really managed, they're just the right length. So if they were like tied down, I think it would look cleaner and tidier. But I think this is probably going to do me. I might like attach some to each other or something, I don't know. Largely, I'm pretty happy with it. Whew. We've got camera still to do. Camera, lights, filament sensor, firmware, other random doohickeys. But I think we've made blooming good progress today. It's a good milestone getting all that wiring in. We're getting something that starts to really look like a printer, although to be honest the top half does not look very different compared to when we started. And I've just realised this drag chain is in the wrong way around. So I'm going to have to change that. Oh dear. Other than that, all pretty good. Camera? What do you mean camera? Camera? How did you find getting a Pi? I have some. So I just used one of those. You also need to build a vehicle 3.1. Potentially, at some point. I've got the upgrade kit. There's a lot to do. The filament sensor, I'm going to be using a BigTreeTech smart filament sensor is what it's called. You can see all the stuff that I've selected for the build in the first live stream video where oh golly, got everything out the box. Something in my eye again. Oh no, I wish I could just visit them and get one. I don't think it really works like that. I've never thought of going to the shop. I presume there's none there, because everyone would want to go there and get them and all this kind of stuff. Anyway, thank you very much, everyone, for joining me for this live stream. Hopefully it was useful for those kind of following along and trying to, I don't know, get some information out of it. Thanks again to OneTwo3D, LDO Motors and BigTreeTech for providing a bunch of parts for this build. I'm going to go get this hair up my eye. I'll see you in the next one. Cheerio, thanks everyone, and goodbye.